go.
Hello class, phones away please. Today we're going to be working on this problem. Use the first derivative test and concavity/inflection points to sketch graph for f double prime of x for f of x equals 1/4 x to the power of 4 minus x cubed plus 7. So first we're going to get started with the constant we have here. So it's going to be 1/4 constant, bring it down, constant multiple, bring it down, and then we're going to go to the power rule, and it's going to be 4x cubed minus another power rule, 3x squared, subtract the 1 from the exponent, and then it's a constant, so constant equals 0. Alright, so now to simplify this a little bit, we're going to multiply the 1/4 with the 4, which is going to give us 1, so it's going to be x cubed minus 3x squared. And then from here, we want to equal it to 0, but it's still kind of complicated, so what we're going to do is we're going to factor out, and we're going to factor out an x squared, so it leaves us with x minus 3 inside. And now we can equal both to 0. So x squared equals to 0, and x minus 3 equals to 0. We're going to square root this, and the square root of 0 is going to equal 0, so x equals 0. And then we have x minus 3 plus 3 equals x equals positive 3. So these are going to be our critical points. And with these critical points, we're going to go ahead and make our sign chart over here. Alright, and we have 0 and 3. Alright, so a number between -infinity and 0, we're going to choose -1. From 0 to 3, we'll pick up 1 as well. And then here, 3 to positive infinity, we're just going to go with 4. Keep it simple. And so now we're going to plug these numbers into our derived function. So we're going to have 1, and we're going to go ahead and use the factor formula. So it's going to be -1 times -1 minus 3. So we're going to have it's -1 squared. -1 squared is going to be positive times a negative, so it's going to equal negative. When this is negative, we know that the original function is going to be decreasing. So now let's try 1. We're going to have 1 squared times 1 minus 3. We got a positive, and it times a negative again. So it's going to be negative. We know that from 0 to 3, the graph is still decreasing. Now we have 4, the last one. It's going to be 4 squared times 4 minus 3, we got a positive and a positive. Positive times a positive is going to stay positive. So we know from 3 to positive infinity, the graph is going to be increasing. And that is it for the first derivative test. Now we're going to move on to Eladio for the second derivative test.
Alright, so now we're going to go on to the second derivative test. So, second derivative test, you find the inflection points, which will also tell us more about the behavior of the graph and how it will look when we plot it. Anyways, so f double prime will be the derivative of f prime, the original function's derivative. So here we have a power, so it'll be bring it down to 3, same base, subtract 1, minus constant 3, bring that down, then power again, so times 2, same base minus 1. We could clean up this function a bit by combining 3 and 2. So to rewrite this part, minus 6 times x. So that would be f double prime, second derivative. So to find the inflection points, set it equal to 0. So you could find the zeros of it. So here you could factor it out. You could factor out a 3 and an x, which would leave you x minus 2. Set it to 0. Still set to 0. Since they're multiplying, you could separate them both to 0. And then here you'll get x equals 0, because divided by 3 is still 0, plus 2, so you get x equals positive 2. And these are the inflection points. So to find the behavior of the graph, we'll make another sign chart. So the points are 0 and 2. Negative infinity, positive infinity are the outermost limits of it. So from negative infinity to 0, you gotta find out what the graph is doing, the behavior of it. So we gotta pick any point. Here we'll pick negative 1. From 0 to 2, we're only left with 1, honestly. And then from 2 to infinity, we'll choose 3. Okay. So now we substitute them in to the original function of f double prime. So it could be this one or the factored version. Factored version is a little easier because once you plug them in, you can find the sign of it and from there multiply them to get the true sign. So here we'll plug in negative 1. You get 3 times negative 1 times negative 1 minus 2. Here 3 times 1 is negative. Negative 1 minus 2 is also negative. So we'll get it positive because negative times a negative is positive. So the behavior for the original function is concave up. It goes like this, somewhat. Alright, so find in between 0 and 2, plug in 1, 3 times 1 times 1 minus 2. Here is positive, 1 minus 2 is negative. Positive times a negative is negative. So the graph is concave down. So, like this. So, for the last part, 3 to infinity, 2 to infinity, put in 3. So I get 3 times 3 or times 3 minus 2. 3 times 3 is positive. 3 minus 2 is still positive. Positive times a positive is positive. Once again, it goes back concave up. So that's the behavior of the graph using the second derivative. Now we'll go back to Ricky, sorry, to find out exactly how the graph will look.
Alright class, look up please. Now we're going to be graphing the original function. So, using the first and second derivative test that helped us with what we're about to do. So, the original function is 1/4 x to the power of 4 minus x cubed plus 7. So from the first derivative test, we know that from negative infinity to 0, it's going to be decreasing. So we can say that the graph is going to be coming down from over here. We also know that the y-intercept is 7, so 2, 3, 4, 5, 6, 7. I'm going to have to erase this. But here's 7, so it's going to come. And we also know at 0 is also an inflection point, so it's going to be changing signs. And then from 0 to 3, it's going to continue to decrease, but at 2, we have another inflection point, and after that, it's going to increase. So the graph is going to look something like this. We have 3, and then from 3 to infinity, it stays positive. So, 2, we have inflection point. At 0, we have another inflection point. And now let's take a look at this graph. We know that negative infinity to 0, the graph's going down. So that's what we have here. We have that. Then from 0 to 3, it's also going down. Here it's going down as well. And it's also concave down from 0 to 3. Because you look at it like that, it's just going down. Also, backtrack a little bit. From negative infinity to 0, which negative infinity to 0 is concaved up, we could also say that it's concaved up. And then at 3, it changes and goes back to concave up and increases to infinity and beyond. And that is how the graph of f of x looks with the help of the first and second derivative tests. Now we're back to Ilaria.
Alright, so now we're going to graph f prime and f double prime. Using the stuff we found from first derivative test and second derivative test. Alright, so for f prime, we can see here that it's negative from negative infinity to 0. So, of course, negative infinity is this way. So times 0, it'll be in the negative range, which is below the x-axis. Alright, so here's another point 3. So you see between 0 and 3, it's also negative. So the graph will stay in its negative, but kind of like curve down a bit. Alright, so after 3 to infinity, it changes to positive. So the graph will cross the x-axis and be in this positive range. So again, from negative infinity to 0, it's negative. From 0 to 3, it's also negative. And then 3 to infinity and beyond, it's positive. Now for f double prime. We see here that we also got positive and negative, so we could do it based on the same idea. So we got our points 0 and our points 2. Alright, so from negative infinity to 0, you see it's in this positive. From 0 to 2, we can see it's negative. And then from 2 after to infinity, it's back in this positive. So positive, negative, positive. You can see here it's like a parabola, and that confirms it because the original is x squared. Alright, so that's how we use the first derivative test and second derivative test to get functions of f, f prime, and second derivative, f double prime. That'll be it.